Hey, what's up, everybody? I'd like to welcome you to the first of a series of tutorials I'm going to be doing on audio programming in openFrameworks, and more specifically, the openFrameworks Maximilian add-on. For this little course, we're going to assume that you have some basic C++ knowledge and also a little bit of knowledge of just some audio programming basics, things like sample rate, buffer size, so on and so forth. If you don't know what those things are, then you may want to start by checking out my audio programming basics course that I have on my YouTube page. So to start off, I'm going to take a different kind of approach to building this project than some other tutorials, in that what I'm going to do is I'm going to assume that you don't know anything about openFrameworks and sound in openFrameworks, and also about Maximilian, because a lot of us just kind of approach these situations like this where we don't really know anything about these things, and we don't really know how to get things going. So rather than just kind of glossing over a lot of these functions, I'd rather dive into the documentation, take a little bit more time just to show, for people that may not be aware, just the way of getting things off the ground, getting a project like this going, and hopefully getting a sine wave going out the speakers. Okay, so we're just going to create a project here. I'm going to call this Maxim Tutorial 1. So we will put this in all my tutorials. So as I said before, you're going to need the ofx Maxim add-on. If you don't have that yet, then what I would suggest is going to GitHub, getting that. I'll post a link below in my description. So we just put ofx Maxim in here as our add-on. Okay, I'm going to generate this project, open it up in Xcode, and get this thing rolling. Great, so here we are. We've got a project open here, and we can see that we have our Maxim add-on here. And what we need to do first, before we do anything, is we just need to ensure that our header file for our add-on is in our ovapp.cpp, where we're going to be doing the bulk of our work. Okay, so we'll just go ahead and include that ofx maxim.h file. Okay, fantastic. So now we're going to approach this as if we don't know anything about sound in openFrameworks. So the way that I like to start is by just kind of diving into the framework itself and just seeing what the framework has to offer. Okay, so I've had a look through this already, but I'm just going to go through these steps for people that don't really know, just so we can kind of start to build up a foundation of knowledge, rather than just going through these functions and just throwing in numbers and variables, and we don't really have any idea what those mean. It would be better for us to kind of build from the bottom and really investigate what these functions are about. Okay, so if we go in here so what we want is a sound stream. Okay, so we're just going to have a look in the header file for this. Okay, we can see that there's some documentation. If I scroll down a little bit, it gives us a little nice description of these things that we're going to need to kind of get things going. Okay, so sound stream controls access to the computer's input and output, which is exactly what we need. So we need an output to put sound out to the speakers. Okay, so in order to start receiving or generating audio, you should have an audio in or audio out function. Okay, and then call sound stream setup. You can find examples of this in the audio input example or audio output example. Okay, fantastic. Okay, so next, let's just go over to our openFrameworks examples. And let's see if we can just find anything else out from our audio output example, because this is pretty much exactly what we want to do. We just want to take a sound, just want to take a sine wave, and we just want to put it through an output. Okay. So what we're going to do is just combine what we've seen with the documentation that we saw previously, talking about the sound stream setup, and the audio out function that we need to get things going out of the speakers. Okay, so if we just take a look at the header file, okay, so we have an audio out that we need, audio out function. Fantastic. We're just going to copy that. I'm going to go back to our avhat header file and just paste that there. Okay. Then what we're going to do is we're going to go down and look at how this is implemented. Okay, so it looks like they just have it here after window resized. Okay, so I'm just going to take this, and normally I would just type this out. If you have the time, I would encourage you just to type it out, because I don't know, I just seem to learn when I type it rather than just being lazy and copy and pasting it. But for time's sake, I'm just going to copy it and paste it here. Okay, so where did we have it? After window resized. Okay, so just gonna paste that there, and boom, there's our audio. There's our audio function. Just gonna take this, put this here, so it's nice and neat. Okay, so there that is. Okay, so now let's just go back. Okay, so we needed a sound stream to get things set up. Okay, and as we can see, we have a sound stream object here. Okay, so I'm just going to go ahead and type that. So of sound stream. Okay. Now let's see. I'm going to capitalize this. Just make sure we're syntactically correct here. And now we're going to see how this is implemented here. Okay, so if we just go into the example. Okay. So we can see that there's a sound stream set up here. Okay. Now I'm looking at this and I know what it means because I've already looked through this, but let's say this is the first time that you're looking through this and you say, oh, I don't know what 2 is. I don't know what 0 is. I don't know what 4 means. So what we do is we just kind of command click in here in setup, and we just see what arguments we're taking here. Okay. So so setup, we have the app itself, which is this, or the app itself. Okay. Number of input of out channels, number of in channels, sample rate, buffer size, and number of buffers. Okay, cool. So we know that we're going to just need a couple variables here. So we know that those are going to need to be type int. They need to be integers. So we are just going to set up a couple integers here. One for buffer size and one for sample rate. Okay. Let's just give those some initial values as is good practice. Okay, so buffer size. Okay, I'm going to go with 512. That's kind of normal. So that just gives us 512 values for our size of our buffer. Just to go through that briefly, buffer size is just the amount of audio or the amount of values that we're holding at one time. So we're going to be able to hold 512 values at one time. Okay, our sample rate, okay, is going to be what is normal for most applications, 44,100 hertz. If you're not sure why I chose that number, go and check out my audio programming for beginners course, and that'll explain to you why I chose that number. Okay, so now we're going to go and we're going to do this setup function. So let's just go back. Okay, just get situated here. Okay, so we got SoundStream.setup. Okay, so we got this, which is this application. We need 2 out channels, no in channels. We're not recording mic in or anything. So sample rate is just our sample rate variable that we've already set up. Buffer size is the buffer size that we've set up. And we're just going to go with 2 buffers. Okay, so that's that. Great, cool. All right, let's see what else we need from this. Okay, so we have our audio out function. So let's see if there's anything in there that's of use to us. Okay, so a lot of the difficulty I find with going through these examples sometimes is there's a whole lot of just kind of unnecessary stuff. It'd be nice if these examples were a little bit more simple rather than, you know, trying to set up an elaborate GUI and so on and so forth. That's just my thinking though. Okay, great. So if we look here, we can see that we have a for loop here. So this for loop is just going through the 512 values, and it's just basically cycling through those and basically putting numbers into those. Values. So what we want to do is just to kind of, I know the way I said that might have been a little bit confusing. Okay, so just to kind of take an aside and try to kind of explain a little bit more specifically what's going on. So if we break down any sound, what we get is really just kind of a vector or a set of numbers. Okay, and those numbers are just telling the speakers where to go, and those values are going to be between +1 and -1. Okay, because that's why that's basically determining how far forward or how far backward your speaker vibrates at any given point. Okay, so the output is really just the instruction that's pushing our value. In this case, it's going to be a sine wave into the speaker. Okay, so you have a sine function, okay, that we're going to create. Okay, just a sine wave, and that sine function is going to generate numbers, and then those numbers are going to tell the speaker specifically where to go at a given time. Okay, at a rate of 44,100 times a second. Okay, so we know that we need this information here, the output information. Okay, so let's just go ahead and copy that information. Okay, and then we'll just kind of set it aside for a later point. So we got our output. Oh, my bad. Let's go back. Let's just go ahead and type out this for loop. Equals 0, I is less than the buffer size, I ++. Okay, and now we know that we need to go into the outputs at some point. So we're just going to go ahead and just type this information. Okay. So we have two channels, okay, the left and the right channel. So this is just instructions for the left and the right channel of which numbers to put out. Okay, so we got output. I'm just going to put space here because I like to keep my code neat like that. +1, so this is our left and right speaker. Okay, so if we just look at our example code here, we can see that, okay, so this is noise, okay, and we know this because we have random values between 0 and 1 that are being pushed into each one of the speakers. Okay, that's just going to produce those random values are just going to produce white noise. Okay, so this is great what we have here. We have an output, we have our DAC set up. Okay, so let's just compile this, see if we've made any errors here. Okay, got to switch this to debug like so. Okay, so let's just compile it, see if we've got anything. Cool. So far we're so good. Okay, so now that's great. So now what we need to do is now we need to create something to go into these speakers. Okay, so we're just going to do a sine wave oscillator and try to patch it into our output. Okay, so once again we're just going to go through that same process of, okay, I don't know anything about Maximilian. I'm looking at this documentation for the first time. What am I looking at? How do I get to the information that I need to get to? Okay, so if we go into our add-ons folder here, into Maximilian, okay, then we're just going to dive in this first layer here. And so we have these type defs of, okay, so we have envelopes, we have delays, filters, sample if we want to do like sample player, FFT. Okay, so we see that we have an ofx Maxi Osc, which is an oscillator, okay? And that's of type Maxi Osc, okay? Now, I don't know what arguments it takes. I don't know what functions are available to me, so we need to find out what we need to do to get this going, okay? So if I just command click into Maxi Osc, okay, so we're going into the class now, and now we see that we have a number of waves that are available to us. Okay, cool. So we have sine wave here, okay, and if I just command click into that, we can see the actual function that we've got here. Okay, so this is just a sine wave function. Fantastic. Okay, so let's just go ahead and try to implement that. Okay, so we need ofx Maxi Osc, right? So let's just go ahead and set up an oscillator. ofx Maxi Osc. Not sure why the autocomplete doesn't work on the header files. Kind of annoying. Okay, so we got that. Okay, so now we need this oscillator to live within our audio out function, don't we? So let's just try my osc. Here we go. Dot sine. So there we go. Sine wave, double frequency. Okay, so let's just make that 200 hertz. Okay. Cool. So now we have an oscillator and we have our output. Okay, so now we need to patch these into, we need to patch the wave itself into the output. I'm not going to worry about envelopes, volume, triggering, so on and so forth just yet. Just trying to get a sound through the speaker for now. Okay, so I'm just going to call this a variable. Okay, so we'll just call this my sound. Okay, so let's see. Hopefully, hopefully this works. If not, I might not be very happy. Okay, so let's just see if this works. It's just going to compile here. Okay, succeeded. Boom, there it is. Okay, so so that was just like a real basic thing. Okay, I didn't do any sort of sound control or anything, you know, which would be something that you would normally do, or we would like, you know, at this point, you know, the world is our oyster. We could add, you know, an envelope to control how that sound actually generates, or we can add triggering, we can add effects. But this is just kind of a basic tutorial just to get sound out of the speaker, just understand, you know, what we need to do to get sound set up. So I hope that was helpful. And for our next tutorial, what we'll do is we'll try to add triggering and an envelope to our sine wave so we can control that sound and when it goes on and off. So until next time, have a great day.